Our subject about last thing we talked about it, the enantiomers. We said we have two compounds. They are mirror image to each other, but they are not superimposable. And this compound, of course, have what? Stereogenic center, and it will be chiral molecules. For this reason, the enantiomers are mirror images that are not superimposable. This is the small definition for the enantiomers. Are mirror images that are not superimposable. Look, mirror image that are not superimposable. So, CH, this molecule, CH, Br, ClF, contain a carbon atoms bonded to the 4 different groups. Look, this is the group, put groups here, not atoms. Talaba, not just atoms, a group. Okay? Groups, you have to be careful about 4 different groups. Okay? About 4 different groups. A carbon atom bonded to the 4 different groups is called tetrahedral stereogenic center. Okay? So, if we have like this molecules, and this molecules bonded to 4 different groups, this carbon that has 4 different groups, it will be what? It will be stereogenic center. Okay? It will be, this carbon, it will be stereogenic center. So, most chiral molecules contain 1 or more stereogenic center. Okay? The molecule must be chiral molecule or not achiral. For example, chiral molecule at least has 1 stereogenic center. Maybe there is 1 stereogenic center, 3, 4, more than 10, 100 stereogenic center, depending on the molecule weight of the molecules, okay? Depending on the size of the molecules. So, the general term of stereogenic center refers to any site in a molecule at which the interchange of 2 groups form stereoisomers. So, if we have like this example, just give me 1 minute. Two, 3, and this. Okay. Now, this molecules, yes, this molecules, carbon that has 4 different groups. Okay. If I change the position of 2 atoms, this or this or this, it will be give you the second isomers. It will be give you the second isomers. Okay. It will be give you the second isomers. So, if I want to make the mirror image for this compound, okay, I have to change the position of 2 atoms, this with this, or this with this, or this with this. Okay? That meaning the change of position of 2 atoms, it will be give you the second isomers. Okay, it will be give you the second isomers. A carbon atom with 4 different groups. Look, a group, not atom. He said groups, not just the atom. A groups is a tetrahedral stereogenic center. So what meaning the stereogenic center again? Carbon that has what? That has 4 different groups. Okay? That has 4 different groups. Because the interchange of 2 groups converts 1 enantiomers to another. It will give you the second enantiomers. We have now learned 2 related but different concepts in the stereochemistry. The first one, a molecule that is not superimposable on its mirror image, is called what? Chiral molecules. Chiral molecules that are not superimposable. Secondly, a carbon atom bonded to 4 different groups is what? Is the stereogenic center. Okay? Is the stereogenic center. These two terms for you. Chiral, what meaning chiral? What meaning achiral? And any carbon at any time it will be stereogenic center or not stereogenic center. Molecules can contain 0, look, can be contain 0 or 1 or more stereogenic centers. With no stereogenic centers, a molecule generally is not chiral. If there is no stereogenic center, if I give you, مثلا, 3 compounds or 4 compounds, I will say to you, any molecules, it will be chiral. Look, and found the stereogenic center. If there is any stereogenic center, the molecules, it will be chiral. Sometimes there is stereogenic center, but the molecules will be not chiral. I will give you, inshallah, in the next slides. So H2O, for example, and CH2BrCl have no stereogenic center and are achiral molecules. For example, this hydrogen, BrOH. Now, this carbon, how many groups that surrounded this carbon? 4. 1, 2, 3, 4. Okay. Are there is 2 identical groups? Yes, this hydrogen, like this hydrogen. That meaning, are this carbon surrounded by 4 different groups? No. That meaning this carbon, it is not a stereogenic center. It is not a stereogenic center. If I change the hydrogen, with another group, like CH3. Now, this carbon surrounded by 4 different groups? Yes, 1, 2, 4 different groups. That meaning this carbon is a stereogenic center, and we put star. Okay? Refer to the stereogenic center. So, are this carbon a stereogenic center? This carbon, yes, surrounded by 4 different groups. By 4 groups, but not different. 3 hydrogen, the same identical groups. Okay? So, if I give you another example, like this, Br. Okay. Now, where's the stereogenic center here in this molecules? Where's the stereogenic center? Look, this CH3, that meaning we have hydrogen. This carbon, not stereogenic center. Why? Because this hydrogen is the same. Okay. Now this carbon, 1, 2, 3, and the hydrogen 4. That meaning this carbon, yes, stereogenic center. Put a star. Okay? Stereogenic center. Go to the next carbon. This carbon, CH3, C2CH3. And we have hydrogen here, and we have this group here. That meaning also this what? Stereogenic center. Okay? 2 stereogenic center. This carbon, no. Why? Because we have 2 hydrogen, identical atoms, not 4 different groups. This, no. That meaning this example has 2 stereogenic centers. Okay? Must be 4 different groups. Talaba must be 4 different groups. Now, with 1 tetrahedral stereogenic center, a molecule is always chiral. أو مهمة طلبة. With 1 stereogenic center, the molecule is always what? Chiral molecule. If molecules has just 1 stereogenic center, 100 by 100, this is a chiral molecule. Chiral molecules, okay? With 2 stereogenic center like this, or more than 2, 3, 4, more than 1 stereogenic center, sometimes the molecule will be chiral, sometimes the molecule will be achiral, okay? How it will be chiral, how it will be achiral? Next slides, you will be see, okay? I will give you some examples. Now, with 2 or more stereogenic center, a molecule may be or may be not achiral, as I say to you. With 2 or 3 or more than 3 stereogenic center, a molecule maybe it will be chiral molecules or it will be achiral molecules. It is clear for you? It is clear? Just we take the stereogenic center, chiral, achiral. Okay? Nothing else. So, when trying to distinguish between chiral and achiral compounds, look, keep in mind the following. Okay. A plane of symmetry is mirror plane that cuts a molecules in half. So, a plane of symmetry that cut the molecules in half, so that 1/2 of the molecules is the reflection to the what? To the other half. So, if I told you, we have a plane of symmetry here, plane of symmetry that cut the molecules to 2 parts. If I put the plane of symmetry here on this side, look, and this side, if I put it in this side, okay, and this side, this atom is different from this atom. Okay, that meaning it is not a plane of symmetry. I will change one of them. Now, are these molecules have a plane of symmetry? If I put the plane of symmetry here, like that, if you look at it like that, if I put it here, okay, to cut this carbon and this two atom, this side is not equal to this side, not the same to this side. That meaning it is not a plane of symmetry, okay? So, if I make like that also, like that, and I put the plane of symmetry in this side, okay, in this side, now, also this atom, three atoms and on the plane, and this atom is different from this. That meaning this part is not the same to this part. That meaning also this, it is not plane of symmetry. Okay, change again. If I put the plane symmetry in this position to cut this atom and this carbon here, okay? Now, this part is equal to this part? Yes, that meaning this is the plane of symmetry. Okay, this is the plane of symmetry. Okay, the plane of symmetry to cut the molecule into same parts. Tamam? Clear? So, here, two examples. Look, this, now, this is plane of symmetry here. Okay, this part is equal to this part. That meaning this molecules has a plane of symmetry. Has a plane of symmetry. And this molecules, for different group, impossible to has plane of symmetry. That meaning this part, if you put the plane of symmetry here, this part not equal to this part. That meaning there is no plane of symmetry. Okay? So, a chiral molecule usually contain plane of symmetry, but chiral molecules don't. Okay? A chiral, always usually has a plane of symmetry. Plane of symmetry. But chiral molecules cannot be has chiral of symmetry. Clear? Okay? This is the difference between chiral and achiral. Chiral has a plane of symmetry. Achiral that don't has plane of symmetry. Okay? Maybe we have here another example. Okay. Everything has a mirror image. This everything has a mirror image. Keep in mind, this notes. Everything has mirror image. The fundamental question is whether a molecules and its mirror image are superimposable or not. If I say to you, draw the mirror image for this molecules, directly you have to think the mirror image is superimposable or not superimposable. Yes, but you have to keep this in your mind, okay? When you draw the mirror image for the molecules. Second, if a molecules and its mirror image are not superimposable, as you said, not superimposable, the molecule and mirror image, it will be what? Chiral. Hardo, it will be both of them. The molecules and the mirror image, it will be chiral molecules. And this chiral molecules and the mirror image also, it will be chiral molecules. The terms stereogenic center and chiral molecules are related but distinct. Okay? They are related with each other, but there is distinguish between of them. Okay? In general, a chiral molecule must have one or more stereogenic center, at least one stereogenic center. The presence of a plane of symmetry, this is the last one, we take the plane of symmetry. The presence of a plane of symmetry make a molecules what? Chiral. Put here 2 or 3 lines. Diamond, if you have a plane of symmetry, the molecule, it will be what? It will be a chiral molecules. A chiral molecules. So, look this homework. He said draw in a plane of symmetry for each molecules. He said draw the plane for symmetry for this molecule and for this molecules and for this molecules and for this molecules. Okay. For example, this molecules. This is the plane of symmetry here? Huh? No, if you put the plane of symmetry here, this part, it will be not like to this part. Okay? The upper part, it will be not same to the lower parts. Okay? If you put the plane of symmetry. Where's the plane of symmetry? Well, here the plane of symmetry. If you put here plane of symmetry, this part, it will be equal to this part. The same. That meaning this molecules has a plane of symmetry, and this molecules, this for you, and this, where's the plane of symmetry here? No, here the plane of symmetry. Okay, and this molecules, here the plane of symmetry. Okay, this homework for you. So just you have I just give you how to draw the plane of symmetry. Look, if I told you, for example, this 1, 2, 3, okay, this carbon, and this, for example, has CH3 group, okay, and this also has CH3 group. Now this carbon and this carbon and this carbon on the plane of the board, okay? So the third group, it will be near from you, front in this plane, and the second, it will be behind to the other side, it will be far from you, okay, like that. This near from you, it will be how? It will be which, yes. And the far from you, behind that, it will be dashed. Okay. For example, I will put here مثلا BR, I will put here مثلا CL. Okay. Now this molecules has a plane of symmetry. Yes, has a plane of symmetry if you put the plane of symmetry in this side. Okay. يعني for more clear for you like that. Okay. مثلا BR and this CL. Okay, where is the plane of symmetry? The plane of symmetry here. Okay, here the plane of symmetry. It will be like that. Cut the molecules in two sides. Okay, on two sides. You can also, if you have some problems with to draw the plane of symmetry, okay, make it like that. Sorry. Okay, like this. Okay, this is the plane of symmetry. So we have the carbon here in the middle. Okay, the carbon here in the middle. And we have this CH3 and this CH3. Okay, and we have BR, this in the plane of symmetry. Okay, so here we have, for example, the BR, and here we have the CL, and here we have the CH3, for example, CH3, and here we have CH3. Okay, that meaning cut the molecules to two parts. Okay, cut the molecules to two parts like this exactly. Here, like this. Okay, to cut the molecules to two parts. Another example, maybe we have another example. So he said here the homework, a molecule is a chiral if it has a plane of symmetry in any conformation. Okay, look, this is also important. Just give me a minute. One, two. Great. Okay. Now, look to these molecules. Are these molecules has a plane of symmetry or not? Like this. Okay, now we have a plane of symmetry here? No. Here. No, like this. Try to rotate, jump, yani don't break the bonds, just rotation, because we have free rotation here, yes? Okay, now, no, there is no. Okay, try here, red with the red, this it will be different parts, yes? Okay, yellow with the yellow like that, this it will be different from here. Okay, different from here. Tamam? Now, if you make free rotation, there is no plane of symmetry. There is no plane of symmetry. Okay, I will change. Just give me 1 minute. Okay, now this is the second example. Are these molecules have a plane of symmetry now, like that? No. From here, this part like this part? No different. Okay, try to make rotation, just rotation. Now, no. Now, yes. Okay, now that meaning this molecules has a plane of symmetry here, from here. This part like this part. I just make rotation, okay? Rotation. Now, for this example, exactly like this homework, he said, there is a plane of symmetry on these molecules, for these molecules. If you look like this, مثلا like this, you will be say directly there is no plane of symmetry, okay? Just before the answer, just make rotation for the bonds. If you spin this group, can be found a plane of symmetry or not? Okay, rotation. So here in this point, yes, we have a plane of symmetry. Okay, in this point we have a plane of symmetry. That meaning, do you remember the conformation? We have مثلا clips, yes. Just we have make a free rotation here to give you the suitable conformation to find the plane of symmetry. So if you look at like this, you'll be say directly these molecules say that there is no plane of symmetry. But before the answer, no, your answer is wrong. This molecules has a plane of symmetry. Just make small rotation and the plane of symmetry, it will be found. Okay? You have to be careful here. Stereogenic center. Stereogenic centers, we said, what meaning is stereogenic center again? Carbon that has 4 different groups, not atom, groups, okay? Groups is tetrahedral stereogenic center, and this carbon must be chia, sp2, sp, sp3, must be sp3, must be tetrahedral. Okay, to locate the stereogenic center, examine each tetrahedral carbon atom in our mix and look at the 4 groups, okay, on the molecules. For example, this CBr-ClFi has 1 stereogenic center because the central carbon atom bonded to the 4 different elements. Okay, 4 different elements, 4 different groups. 3-bromohexane, the 3-bromohexane also has a stereogenic center. Look, here, this carbon, yes, sp3, but not for different group. This carbon, sp3, but also not for different group. This carbon, sp3, but this has 4 different group. This group is CH2, CH3, and this group is CH2, CH2, CH3. Don't say to me, this group like this group, because this carbon bonded to this CH2 and this carbon bonded to CH2. No. Okay? We take all the atoms as one group. This group, not like this group. Either ethyl or this or propyl. That meaning ethyl, propyl, 2 different group. And this group also is different. That meaning this carbon is a stereogenic center, has 4 different groups. Okay? HBr, ethyl, propyl. So, always from the consideration, all carbon atoms that cannot be tetrahedral stereogenic center. So, directly, if I give you examples, طبعا this is small molecules طلبة, but if I give you مثلا big structure, maybe like this, okay, or maybe bigger, like this, okay, don't come to everyone and thinking how this it will be 4 different or like that. Directly, CH2 and CH3, this is not a stereogenic center. Every carbon has 2 hydrogen or 3 hydrogen. This carbon, it is not stereogenic center. Okay? Directly. Yani, if I come to this example, this CH3 not a stereogenic center. CH3 not a stereogenic. CH2 not a stereogenic center. CH3 not a stereogenic center. But this CH, you have to think. R has 4 different group hydrogen, and this group and this CH3 the same, that is not a stereogenic center, and like that. Okay? يعني دائما CH2 CH3 إهمالك directly. Okay? Like this, CH2 not, CH2 not, CH2 not, CH2 not, directly. CH2 and CH3 can be ignored from your selection. This is the meaning. Always CH3, CH2, it is not a stereogenic center. And also, every carbon, sp and sp2, also it is not stereogenic center. So, we go to the example again. This carbon is what? sp2, not a stereogenic center, sp2. And this carbon, sp2, not a stereogenic. This, not a stereogenic. This, not a stereogenic. Like that, okay? Every sp2, sp3, sp and sp2, it is not a stereogenic center. تمام؟ واضح؟ So, larger organic molecules can have 2 or 3 or even more than 100 stereogenic center. Okay? Propoxyphene and ephedrine, these compounds, each contain 2 stereogenic centers. This compound, look, this compound, for example, CH3 not a stereogenic center. This, not. This, sp2, nah. Oxygen, nah. This, CH2, not stereogenic center. Okay? And this carbon, yes, this carbon has 4 different groups. Phenyl and benzyl and this group and this group. That meaning this carbon is what? Stereogenic center. And this carbon also has 4 different groups. And this CH2, not. CH3 by 2, not. Okay? The same example here. This carbon and this carbon, they are stereogenic center here. The fructose, look, this is the fructose, simple sugar. Fructose also has, this is stereogenic center here, CH2? No. This carbon? No. Why? Because this sp2. And this, yes, 4 different group, H, OH, and this group, and this group. And this carbon, yes, is stereogenic center, this is stereogenic center, this not stereogenic center. Now, locate the stereogenic center in each drug. Where's the stereogenic center here? Where's the stereogenic center here? This homework for you. Another homeworks. Locate any stereogenic center in a given molecules. This is condensed structure. Okay? If you want, first step, convert the condensed structure to the skeletal structure and see are there is any stereogenic center or not. Okay? Also, you can directly select it from here, but the easier one if convert the structure to the skeletal and then answer. Look at any stereogenic center and given molecules here. Given molecules. So this is stereogenic center? No. This, no. This here. This here. Stereogenic center or no? No. Why no? Because this group is like to this group. Okay? Both of them CH3. That meaning has 2 identical groups. It is not a stereogenic center. And go like that. This, no. This, yes, is stereogenic center. This, no. This, yes, it is a stereogenic center. This, no. This, yes, is stereogenic center. That meaning we have 1, 2, 3 stereogenic center here in this example. Okay? Do you have a question? Is it clear for you the stereogenic center? Huh? Is it clear? Okay. And also this homework for you. How many stereogenic center are there in this compound? Okay, drawing a pair of enantiomers. Now, how we can draw the enantiomers? Any molecules with 1 tetrahedral stereogenic center is what? دائما is what طلبة? With 1 stereogenic center, it must be chiral molecules. Must be chiral molecules with 1 stereogenic center. And exist as a pair of enantiomers. دائما, this molecules has mirror image. This mirror image must be what? The enantiomers for the molecules. Okay. Now, 2-butanol For example, where is the 2-butanol? This is the 2-butanol. This, okay, 2-butanol. 2-butanol has one stereogenic center. Yes, this is the stereogenic center. And to draw both enantiomers, use the typical convention for the depicting the tetrahedral carbon or tetrahedral the plane, and place 2 bonds in the plane, one in the front of the plane and the other it will be wedged, and the other is behind the plane, it will be dashed. So 2-butanol طلبة. Two butanol, methane, ethane, propan, butan. 2-butanol, we have here what? We have OH, okay? OH. And here we have hydrogen. Okay? This work? No problem? Okay. Now, are this stereogenic center? No. 3 hydrogen, SCH3. This? No. This? Yes, this is the stereogenic center. Okay. Star. Put a star. And this? No stereogenic center. Okay. To draw the first isomer, where is our stereogenic center? This carbon. Put the carbon here. This is the carbon. Okay. Now, this carbon, 2 bond on the plane of the molecules, on the plane of the board, okay? This, 2 bond, this, and this, 2 bond. And the third bond, it will be near from you, okay? Near from you, it will be what? It will be washed. And the fourth one, sorry, it will be on the behind of the plane, okay? Yani far from you. It will be like that. So now, how many groups we have? 1, 2, 3, 4. Okay. Put it عشوائي as you want. Any group with this you want? عشوائي. CH3. يلا أبا CH3. This? H? H. Not like the example. Okay. This? OH. And this must be CH2, CH3, okay? CH2, CH3. Now, I have to draw the mirror image for this compound. This is the first isomer, okay? Okay, put bond, 2 bond here, 2 bond like this, here, and the second like that. This is the third bond. And this is far from you, the last bond. Okay. Now, to draw the mirror image for this, exactly, it will be the same for this part. That meaning CH2, CH3, it will be here or here or here or here. Here. Okay? CH2, CH3. And this, OH. And this to the up, hydrogen. And this, CH3. That meaning now this mirror image or not mirror image? Yes, mirror image. Exactly mirror image. That meaning this, the second enantiomers for the molecules. This is the 2 enantiomers. This is the way how we can to draw the enantiomers for the molecules. Okay? So, he said firstly, then he said where is? Then form first enantiomers, that is enantiomers number I, and by using to draw the mirror image for this compound, it will be give you the second enantiomers. Then draw the mirror plane and arrange the substituent in the mirror image so that it will be give you the same reflection for this part. This side exactly the same for this side. They are the same mirror image. Okay. So A and B, this A and B 1 and 2, they are what? They are enantiomers. Enantiomers. If you want to test, are this? It will be superimpossible to this or not superimpossible? Okay, it will be not superimpossible. You can't imagine, or you can try to to make the super impossible for this compound, it will be not impossible. Okay, not impossible. It will be enantiomers. Two other pairs of enantiomers are drawn in figure here. So another example. This another example is the alanine. Okay, amino acid. The alanine amino acid. The mirror image for alanine. This are these compounds. They are super impossible or not super impossible? They are not super impossible, and it will be enantiomers. Again, super impossible, not super impossible here. For example, just give me 1 minute. So, do that. 1 second here. Okay. Now, this is the first isomer. Okay, again, this is the first isomers. Okay, this is the first isomers. Mobile, put the mobile in the chair. Put the mobile in the chair. Okay. This is the first isomer. I will draw the second isomer. This second isomers. Okay, they are mirror image to each other. Okay, they are super impossible or not super impossible like that. If you rotate like that, no, there is no possibility to make both of them aligned, all the atoms and the atom to each other. Okay, they are not super impossible. Look, the green with the green, yellow with the yellow, but here we have a problem with the red and blue. Yes, so they are not super, but they are mirror image. Mirror image, but they are not super impossible. For this reason, they are enantiomers. Enantiomers. Okay, enantiomers. The same thing here. Also the same thing here. This is the other example. Look, this exactly the mirror image for this. They are enantiomers because that has one stereogenic center. These molecules, they are chiral molecules. This is chiral molecule. This is chiral molecules. Do you understand how to draw the enantiomers? Okay. Select the stereogenic center carbon. Where is it? This. 2 bonds on the plane of the paper, on the plane of the board. And the third bond, it is near from you. And the 4, it is in the behind. Okay, behind the plane, far from you. And put the groups. عشوائيا put the groups. And draw the mirror image to give you the second enantiomers. So locate the stereogenic center of each compound and draw both the enantiomers. Where is the stereogenic center here? How many stereogenic center? Refer to the stereogenic center and draw the enantiomers. This homework for you. Are this stereogenic center? For example, this is stereogenic center? No. This? Yes, because it has CH3 hydrogen Cl and CH2 CH3. Okay, so this, no, why? Because it has 2 hydrogen, identical group. This, no, that meaning just one stereogenic center here. Draw the first isomer, mirror image to give you the second isomers, the second enantiomers. Okay. Now, stereogenic centers in cyclic compound. So now we go to the cyclic compound, how we can find the stereogenic center. Now look, does methyl cyclopentane has this compound? This methyl cyclopentane, this compound, have stereogenic center? All the carbon atoms are bonded to the 2 or 3 hydrogen atoms, except one, this carbon. This, look, CH2. This, CH2, not stereogenic, CH2, CH2. This, CH3. This, CH, yes. This may be or not to be stereogenic center. You have to test. You have to test. Are this carbon surrounded by 4 different groups or not? This group CH3, this group hydrogen, and this here, it will be same group or different groups? Okay, you have to test it just step by step. The ring of carbon bonded to the methyl group. Next, it will be compare the ring atom and the bond in both sides, okay, in both sides of the cycle. And continue until to the point or different or reach the both of the carbons or the bonds here in the cycle. This it will be continuity here and this continuity here. And look, are these two parts for the cycle to be different or not? For example, look here. Now this carbon, this hydrogen number 1, and this CH3, and this carbon. Look, here CH2, CH2, there is no different. Here, CH2, CH2, there is no different. That meaning this part for the cycle is like this part, the same to this part? Yes. If they are same, that meaning this carbon is not stereogenic center. Is not a stereogenic center. Look, this part, exactly the same for this part. Okay, another example. For example, we take this. Now, what is the name of this compound? This cyclohexane. This cyclohexane. Okay? Cyclohexane. And what we have here? Methyl, CH3. Okay. This stereogenic center? No, CH2, 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 CH3, and CH. This. We have to test this now. Now, this surrounded by CH3 and hydrogen. We have hydrogen here. But we don't draw the hydrogen because this is what? Skeletal structure. Now, go to here to test the cycle. Are this cycle, it is that can be all half mirror image or not? This half of the cycle will be like the same for this half or not? Okay. Now, go. This CH2, CH2. CH3, CH3. And here, CH2. Are this part the same for this part? Yes, they are same. That meaning this is not a stereogenic center. Not a stereogenic center. Okay, another example. What's the name of this compound? A. 1, 2, 3. Okay, good. 1, 2, 3. 3-methyl cyclohexene. Okay, now come this CH3, one group, and here we have hydrogen, second group, and this CH2 and this CH. That meaning different here. This different. CH2, CH different. Okay, CH2 the same. Are this part same to this part? No. That meaning yes, this, yes, it is stereogenic center. Okay, the stereogenic center for cyclic compound, it will be like that. Another examples, maybe we have another examples. Okay, I can give you many examples. Just go to the next slide. No, look, if I told you like this exactly, draw the enantiomers for this compound for 3-methyl cyclohexene. Okay, number 1, for example, put all this cycle on the plane of the board. This on the plane of the board. This here. Okay. That meaning we have two remaining bonds. One of them it is on this side, near from you. It will be like that. And the second, the fourth one, the last one, it will be the front of the plane. It will be like that. Okay. One of them hydrogen and the other is CH3. Draw the mirror image directly. Draw the mirror image. This is the mirror image. This. And here we have the wedge bond. And we have here the dash. This hydrogen and this the CH3. This enantiomer number 1. This enantiomer number 2. Okay. Are this compound superposible? No, they are not superimpossible. They are not superimpossible. Okay, they are not superimpossible. Enantiomers, 2 enantiomers. Okay, now this compound, look, This has one stereogenic center. Where is it? Here, the stereogenic center. Okay? Not this CH2, not this CH2. This is sp2, not this, not all this. Just we have one stereogenic center here, and can be found as two enantiomers. This enantiomer number 1 and this enantiomer number 2. They are mirror image to each other, but they are not super impossible. That meaning this group number 1 or this group number 1, hydrogen group, okay? This is the hydrogen group, and this is the group number 2, this is the group number 4, okay? So they are not super impossible, they are enantiomers. Now, are this has a stereogenic center or not, this compound? Test it. Yes. Maybe no? Maybe no? This carbon is stereogenic center or not? Huh? Why not? Tamam. This CH3 and this here hydrogen. Go. CH2, CH2, the same. The second, go CH2, CH, different. That meaning this part is not equal to this part. That meaning this is stereogenic center. Okay? This is stereogenic center. So just be careful here. As you test the aliphatic compound, you have to test the cycle compound also. I said always you have to think about the groups, not the atom. Groups, okay? So if I give you here carbon with hydrogen with Br, for example, just think about the group. Now, CH3, CH3. Now, this carbon is stereogenic or not a stereogenic center? Not. Why? Because this CH3 and this CH3. If I put like that, carbon, 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 and carbon to carbon, like that, all of them is hydrogen. Okay. Now, test it. This carbon, hydrogen Br, yes, hydrogen Br. Now, this bonded to the sp3, CH2, and this also CH2. Don't say this that they are same atoms. Okay? If CH2 is same to CH2, go to the next atom. Okay, now CH2 bonded to what? To CH2. Here CH2 bonded to what? CH3. That meaning we are different here, different point. So this is group number 1 and this group number 2, they are not same. They are not same. For this reason, we say the stereogenic center have 4 different groups, not atom. Not atom. Okay, not groups. Okay? Groups. Hold the groups, yeah. All the group like that. All the group, they are different. For this reason, here you say to me, this CH2 is CH2 the same. That means it is not a stereogenic center. Your answer is false. You have to go to the next atom. What is the next atom here? CH. What is the next atom? CH2. That means they are different. Okay? Is it clear for you now? For cyclic. Okay. For example, this. Where is the stereogenic center here? This compound. Yalla, you have to think. This is stereogenic center? No. This? Yes. Why? Because we have CH3 and hydrogen, and this part is not like to this part. Okay, this number 1. This? Yes, this is stereogenic center number 2. This CH3 hydrogen, and this part not like this part. Stereogenic number 3, this stereogenic center. And this? Yes, stereogenic center number 4. That meaning this molecules has 4 stereogenic centers. This 4 stereogenic centers. Okay? Clear? Do you have a question? Do you have a question? No question? Good. Now, also you have homework here. He said locate the stereogenic center in each compound. Where is the stereogenic center here? Refer to the stereogenic center. Just put stars, okay? Put stars. Labeling stereogenic center with R and S. Okay, so if we if I told you this, they are enantiomers. Okay, what is the name of this? For example, مثلا 3-hydroxybutanol. And what is the name of this? Also, it will be 3-hydroxybutanol. That meaning enantiomers, they has identical names. We say, I told you before that the names, it will be the same. They are identical IUPAC names, the same names, but different what? Different arrange of the atom around the stereogenic center here. Okay, how we can distinguish between this and this? Okay, what I say to you, the right enantiomers, left enantiomers? No, it is not useful. When you're writing or when you read the books and when you مثلا write research on when you explain for your friends. Okay, that meaning we have to distinguish between these two isomers by letters. For this reason, the science try to use ROS. مثلا R enantiomers, S enantiomers. Okay, what meaning R? What meaning S? We will be see. Okay, anytime we put S, anytime will we use R. ROS enantiomers. Okay, so ROS system used to distinguish between the isomers, the R and S. Look, because enantiomers are two different compounds, we need to distinguish between of them. Anyone it will be S, anyone it will be R. Okay, ROS just examples. Okay, ROS letters. Okay, but what meaning S? What meaning R? This will we see here. For that has the same IUPAC name, but we put RX prefix to the name. يعني مثلا we said R مثلا 3-butanol or R2-butanol and we put S2-butanol. Okay, S it will be precede the name of the compound, the IUPAC name. To distinguish an enantiomers ROS, first assign the priority. طبعا the priority I think it is not new for you. We take it maybe last year when we EZ, yes, cis trans to EZ system. We take this system. What meaning priority? Dependent on the atomic number, just easy system, depend on the atomic number for the groups. And each group bonded to the stereogenic center, we put 1, 2, 3, 4. And then use the priority to label one enantiomers R and one enantiomers. Okay, we take the priority system, how to assign the priority system. Okay, number one, this the rules for the priority, how to, مثلا, this group مثلا, it will be number 1, this group it will be number 2, this it will be number 3, this it will be number 4. For example, I have to put numbers here, 1, 2, 3, 4. So, assign priority 1, 2, 3, 4 to the atom directly bonded to the stereogenic center in what? In order of the decreasing the atomic number. Decreasing. تمام? Decreasing. Not increase. Decrease the atomic number. That meaning if you have, for example, hydrogen or oxygen, anyone has low atomic number? Hydrogen. And the oxygen, it will be the highest one. That meaning anyone it will be number 1, anyone it will be number 2? No. Yes, بالعكس. Okay? The oxygen will be number 1 and the hydrogen will be decreasing. I say to you, decreasing the atomic number, not increasing the atomic number. Okay? Kish atomic number Belinda, it will be the first one. Okay? It will be the first one. Okay. Example, this example. Look, hydrogen, fluor, chlor, brom. Okay, you know fluor, chlor, brom. Anyone is highest the atomic number? Of course, the brom, it will be the highest one. That meaning it will be number 1. دائما طلبة always hydrogen to be take number 4 at the last. الأسبقية, the last one. دائما the hydrogen take number 4. The hydrogen. If you have hydrogen, always hydrogen take number 4. So this brom and then Cl it will be number 2 and the fluor it will be number 3. The hydrogen at the last. دائما. At the last it will be take number 4. Another example like this. Look. No, not this example. Okay. Okay. 4 3 1. OH. يلا. دائما hydrogen number 4 دائما. The last priority for the hydrogen. Okay. Anyone it will be take number 1. Oxygen, brom, or carbon? Anyone has high atomic number? Oxygen, chlor, or brom? Look to the brom. Brom. That meaning this it will be number 1. Okay. Oxygen or carbon? Oxygen number 2. And then number 3. That meaning we put this number. Now this is right numbers, right priorities. Okay, right. Firstly is the Br, secondly oxygen, thirdly it will be carbon, and fourth it will be for the hydrogen. Easy, according to the atomic number. Okay. Rule 2. If two atoms on the stereogenetic center are the same, assign priority based on the atomic number of the atom bonded to this atom. So, for example, this, look, hydrogen, methyl, ethyl, يعني hydroxyl group, methyl, ethyl, and the hydrogen. Now, hydrogen diamond, number 4. Okay, 4, خلاص. Okay, now CH3, CH2, and OH. OH, oxygen, and 2 carbon. Anyone is the best? Is the higher priority? Oxygen. Oxygen will be take number 1. Now, this 2 or this 2, go. This carbon bonded to the CH3. That meaning this carbon bonded to the 3 hydrogen. And this carbon bonded to 2 hydrogen and CH3. Okay. This carbon like this carbon, there is no difference between these 2 atoms. No difference. Next atom, this carbon bonded to the hydrogen. This carbon bonded to the carbon. That meaning anyone it will be take number 2. This it will be take number 2. And this it will be take number 3. This group has the higher priority because the carbon bonded to the carbon. But here the carbon bonded to the hydrogen. That meaning it will be lowest priority. واضح? Clear? Okay. Now, give you example here. Yeah. Like this compound. Hydrogen diamond, number 4. We have here carbon, and we have here carbon, and we have here oxygen. Anyone it will be take number 1? Oxygen, خلاص. Now, anyone it will be 2, anyone, this 2 or 3, and this 2 or 3. Okay, now this carbon bonded to the carbon, and this carbon bonded to the carbon, no different. Carbon, 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 carbon. Okay, go again to the next atom. This carbon bonded to the carbon, this carbon has 3 hydrogen. 1, 2, 3 hydrogen. This carbon bonded to the carbon, this carbon bonded to the CH3. That meaning this it will be the higher priority. Okay, this it will be take number what? 2. And this it will be take number 3. Okay, واضح؟ جيد؟ تمام. No question? Okay. If isotopes are bonded to the stereogenic center, assign the priority in order decreasing. Look, decreasing what? Decreasing mass number. Mass number. Okay, if you have hydrogen atom, deuterium and tritium. Okay, look to the mass number. For the hydrogen, mass number is 1 because it has 1 proton. For the deuterium, mass number is 2. Why 2? Because it has 1 proton and 1 neutron. For the tritium, the mass number is what? 3. That meaning because it has 1 proton and 2 neutron. Look mass number 3, 2, 1. Anyone it will be higher priority? Tritium. Tritium, it will be higher priority when number 1, and deuterium number 2, and the hydrogen diamond, I told you are the last. It will be number 3. So if you have here for example this D and CH3. Okay, this number 1, this number 3, and this number this. Okay, now 1 hydrogen diamond 4. Okay, this 2 or 3, this 2 or 3. This what? 2. 2. Why? Because carbon has higher than deuterium. Okay, now deuterium or hydrogen, طبعا deuterium it will be number 3. Okay? This is the isotopes. 4. To assign the priority to an atom the part of multiple. Okay. If you have double bond or triple bond. Now look. Carbon CH2OH, carbon aldehyde group, for example, aldehyde group. Yalla. This hydrogen diamond, number 4. Okay, now this carbon bond to the carbon, and here carbon, both of them carbon. And this oxygen, طبعا oxygen number 1. Now, this carbon and this carbon, no different. Both of them is carbon. Okay, this carbon bonded to the oxygen, and this carbon also bonded to the oxygen. Also the same, no different. Okay, what we have to do here, diamond, if you look and you found double bond or a triple bond, if you have double bond, multiply by 2. What meaning multiply by 2? يعني this group multiply by 2, يعني it will be like this. It will be carbon, 2 carbon, and 2 oxygen like that. Multiply by 2. Okay, anyone is the higher priority? Just carbon, 1 oxygen, or 2 carbon, 2 oxygen? Yes, 2 carbon, 2 oxygen. Okay, that meaning this it will be number 2, and this it will be number 3. Okay, if you have a triple bond, the same. If you have a triple bond, the same. Remove. Now, for example, you have CH double bond CH2, and here you have carbon a triple bond CH. Yalla, assign the priority of this groups. Carbon bonded to the carbon, here carbon bonded to the carbon, no different. Okay, 2 carbon double bond, that meaning this is equal to this. 2 carbon multiplied by 2, yani 4 carbon atom. Or this triple bond, that meaning is the same to this group has 6 carbon atom. Anyone has higher priorities, 6 carbon atom or 4 carbon atom. That meaning this it will be number 2, and this it will be number 3. Okay. Homework. This is the same. Okay. Now assign R and S to the stereogenic center. Assign R and S to the stereogenic center. Okay. How? One. بلا بجت عبد الرحمن خليه يرجع بعدين. Okay, sit down. Assign and RS to the stereogenic center. How we can give R and RS letters to the enantiomers. Now, he said label each enantiomers and RS X. For example, give me this, it will be R or S, this it will be R or S. Okay. Step number 2, we have steps. Assign the priorities for 1, 2, 4 in each group bonded to the stereogenic center. We know this. The priority of the 4 groups around the stereogenic center and 2-butanol. For this 2-butanol, we give the rule number 2 here. Diamond, this oxygen will be number 1. Diamond, this number 1. Hydrogen, number 4. With this 3 and 2, 3. This 2, 3 or this 2, 3? This 2 and this 3. That? Sorry, this 2. Sorry, yes, this 2 and this 3 because this 2 carbon atom and this 1 carbon atom. Now, this is the priority for the OH and ethyl and methyl and the hydrogen. We put numbers now. Go. Orient the molecules with lowest priority groups for bag on dashed. Okay, bag on the dashed. And visualize the relative position of the remaining 3 groups. He said, look. Okay. Any color, it will be hydrogen. You have to select the color. Anyone. For example, anyone will be hydrogen atom. Yellow? Okay, the yellow. This is the yellow. Now, this is the yellow and the hydrogen and this 3 different group. He said the first one, put this here in the back side. Okay, in the back side. He said, look, he said, orient the molecule with the lowest priority here, the bag and the back side, dash it will be the dash it. Look, dash it to the hydrogen. Okay, that meaning if your hydrogen here, put the hydrogen in the back side. If your hydrogen like that, put the hydrogen in the back side. Okay, and look from here, to the hydrogen. Like that. Look from here to the hydrogen. If I want to test this molecule, I will put this in the back side and I look from here. Do you understand? Look from here. And visualize the relative position of the 3 remaining groups. Okay, this it will be hydrogen to the back side. How many groups remaining? 3. And he said test this 1, 2, 3, or this it will be 1, 2, 3 like that. 1, 2, 3 or 1, 2, 3. It will be 1, 2, 3 according to the clockwise, يعني وكي عقرب الساعة, or counter clockwise, 1, 2, 3. Okay? So here, step by step, just for each enantiomers of 2-butanol, look toward the lowest priority groups drawn behind the plane. Okay? Down of the carbon and hydrogen. Here, look, he said look from here and 1, 2, 3. This is the remaining group. Okay? So this it will be 1, and this it will be 2, and this is like 1, 2, 3. Okay. For the second enantiomers here, if I have the second enantiomers, look, this is enantiomer number 1. Okay? I put the hydrogen to the back. It will be, for example, 1, 2, 3. Okay? This enantiomer number 2, I put the hydrogen to the back. It will be 1, 2, 3. بالضبط reverse to the enantiomer number 1. Okay? So if you have 2 enantiomers like that, both the hydrogen to the back, look, this 1, 2, 3, and this will be reverse. One of them like that, and the second like that. Yes? Is it clear? Okay. So, look, one of them it will be 1, 2, 3, and the second will be 1, 2, 3. Okay? Look and test the position of the 1, 2, 3, the 3 remaining groups. So, for each enantiomers, look toward the lowest priority groups drawn behind the plane down to the carbon-hydrogen bond. This will be carbon-hydrogen bond. Trace a circle from the priority groups 1, 2, 3. Now he said, if you have, for example, this, you select the hydrogen in the back side, and you have to test. He said put cycle. If you say this 1, 2, 3, and your cycle will be like that. If you say this 1, 2, 3, the cycle will be like that. Okay? مع عقرب الساعة أو عكس عقرب الساعة. Okay? It will be or clockwise or counterclockwise. So, the letter R or S precedes the IUPAC name of the for enantiomers to butanol. So, if the direction of the circle according to the clockwise, it will be what? It will be what? R isomers. It will be R isomers. Of the direction of the circle, it will be counterclockwise. It will be what? S isomers. خلاص. أبا S isomers, أبا R isomers. Clear? Okay. So, for example, here, look, OH, it will be take number 1, and CH2, CH3 take number 2, and CH3 it will be take number 3. If this hydrogen behind the plane, and you look from here, it will be 1, 2, 3. يعني according to what? To the clockwise. وكي عقرب الساعة, it will be R isomers. عكس عقرب الساعة, it will be S isomers. Just خلاص R isomers, S isomers. Okay? No question? Okay. Label the following compounds are R and S. Okay. I have to stop here just to this slide. Okay. Just we have example here. Okay. Label the following compound are according to the S and R system. This, just we take example. This now take it. This is far from you, the hydrogen. You have directly. Okay, Cl or Br, it will be take number 1. Br, this one. And CH2, CH3, it will be number 3. That meaning 1, 1, 2, 3. يعني S or R? S. Okay, good. Where is S? S isomer. Look. Yani it's easy system. Just look it and you have to look around the priorities. It will be according or reverse to the clockwise. How do you assign R's molecule when the lowest priority group is not oriented toward to the bag side? Okay, look here, inshallah, next lecture, we talk about this, how you can arrange the atom. Look, Bedeng, look to here, look to here. If your hydrogen here, for example, if your hydrogen here on this side, near from you, and on the paper, when you answer the question, you don't know how to rotate like that. Okay, here, if you have the molecules and rotate, it will be clear for you how the group it will be arranged to each other. But here on the board, if the hydrogen here, and I say to you, are this isomers is S or R, how you can imagination the rotation for the molecules on the paper, okay, when you draw it on the paper. For some students is easy, for other students is difficult. They cannot imagination how the molecule will be reversed like that. Okay, so we have system for some students can be used if you have difficult to imagination the molecule how it will be rotate. So, for example, if I want, look, if I want this a blue color to put it here in the back side, the red color it will be where is it? Okay, look, some students they said it will be here. No, it will be here. It will be like that. This is the problem here. Okay, if I told you I want this on the upper side, where's the blue color? This blue color. Some students they said if you convert this here it will be go to the front side. So we have problems here when you rotate the molecules. Okay, for some students I told you it is easy. They can imagination how it will be rotation and where's the groups. So for some students, for other students it will be slightly difficult for them. So we have system here how we can draw the structure after rotation, after we make rotation. Okay, why? Because when you put R and S system, we have to put always the lowest priorities to the back side. Okay, so now where's my method? I look from here, where's the hydrogen? This is the hydrogen. Now I have to put the hydrogen in the back side. Okay, so I have to rotate like that and look to the priority. It will be S or R. It will be S or R. Okay, this inshallah to the next lecture. And if you have a question, please, it is time for questions. Do you have a question? No question?